Let's do one more. Substitution example 3. So you should try this one on your own, or at least get started on it. And I'll walk around and see where you're at. But here's the system. 4x plus 6y is equal to 12, and negative 2x minus 3y is equal to a negative 6. So try to solve this. Well, let me give you a hint. We can solve this with substitution. Well, this isn't a great example for substitution, actually, but we could solve it. But what would we have to do? What's that? Times this one by 2? Not times it, but divide it by negative 2, right? We'd have to get one of the variables by itself. So notice, we can do it, but I don't want to do it. I want to focus on some other things. This would not be a good example for substitution because why? What was the first step? So the first step was we have to figure out if we've got a variable with no coefficient, right? That we can write y or x by itself. Okay? That was the first thing that we wanted to do. Could we do that easily with this example? No, because I've got coefficients with the x and the y. So you can do it, and you should try it, but it's a good example of one of the things that we have to do is learn several different methods, and we want to learn which method is best in which case. So this is a good example of when not to use substitution, because there are coefficients on all the variables. So we'll just stop there. So what I'll do though is go into an elimination example. And we'll use this system for elimination. Negative 2x minus 3y is equal to a negative 6. Okay, so what's the root word for elimination? Eliminate. So for elimination, we want to, instead of substitute, we want to eliminate one of the variables. By adding or subtracting a multiple of the other equation so that any one of the variables will drop out or eliminate, right? So let's look at our equation here. What could I do if I wanted to eliminate the x? To eliminate the x, now remember, what we're going to be doing is adding or subtracting these two equations. If I want to eliminate the x, notice that I've got a 4x here, and I've got a negative 2x here. So I could eliminate the x by multiplying equation 2. So I'll put the equations in parentheses. Okay, equation 2 by what? By the number 2, and doing what? Adding. So here's how that works. If I wanted to eliminate the x, then I would go 4x plus 6y is equal to 12. All I'm doing is I brought this one down. Now multiply this equation by 2 and write it. Negative 4x minus 6y equals, what's negative 6 times 2? Negative 12. Now we can add these. So when I add an equation, I add the left-hand side and the right-hand side. What's 4x minus 4x? What's 6y minus 6y? Plus 0, 0 plus 0. Bring your equals down. What's 12 minus 12? 0. So we have the equation 0 equals 0. Is this true? So this is true. What do you think that means? Right, so this means that there are infinite solutions, and this is a dependent system. And how would I write the solution for a dependent system? Well, it's not all real numbers because we're talking about points, right? Not just numbers. But how would I describe a bunch of points on a plane? So notice that this is some equation of a line, and so this is some equation of a line, but it's dependent, so it's like this example where it's on top of each other, right? So every point on these lines is a solution. How would I describe those points? I can describe them with any one of these equations. So there's infinite solutions. It's a dependent system. Any of these equations describes your solution. Does that make sense? Because what it's saying is that this is an equation of one line. This is an equation of another line right on top of it. So they're actually the same line. So I can use any one of these equations, and that is my solution. I'm not going to worry about that too much, as long as if you can identify when you're trying to do elimination or substitution, if you get a true statement. Okay, there was a problem that was like this on your last test. You get a true statement, you have infinite solutions, and we call that a dependent system. Any questions?